Hi everyone, welcome to the FI rSeries learning. This is the 7th chapter and in this video we will walk through the basic tenant setup on rSeries. As part of this video, we will configure both tenant 1 and tenant 2 with the following initial settings. Task 1. Change the tenant default password. Task 2. Activate the tenant license. Task 3. Provision the required tenant modules. Task 4. Renew the tenant certificate using the tenant hostname and IP address. Task 5. Configure the tenant hostname, time zone and root password. Task 6. Set up the DNS servers and domain names. Also verify the name resolution. Task 7. Configure the NTP servers and verify the time synchronization. Task 8. Verify LAG interfaces are inherited from the host to tenant. Task 9. Verify the VLANs are inherited from the host to tenant. Alright, let us get started. We are setting up tenant 1 as prod lb1.lab.ae on rSeries host1.lab.ae. Task 1. Change the tenant default password. Open a new tab in browser and enter the BigIP tenant management IP address. Then press enter. This will take you to the login page of the tenant. Here enter the default username and password, which is admin and admin. Once you enter the default username and password, the tenant will prompt you to change the default password. In order to change the default password, enter the current password, then type the new password and confirm the new password. Once you've done it, click Save to apply the changes. The password has been successfully changed. You can log in to the tenant using your new password. Task 2. Activate the tenant license. You are logged into the tenant which is still in the default configuration. We are going to run the setup utility to complete few basic settings. In order to perform this, click Next on the setup utility. This will take you to the license section. The licenses are inherited from the rSeries host. Important points to note here. FI rSeries tenants cannot have different licenses from the rSeries host. The license is applied at the host level, meaning all the tenants inherit the same license from the host. In our lab, the tenant has inherited LTM, ASM and APM license from the host. Click Next to activate the FI tenant modules based on the inherited licenses. Task 3. Provision the required tenant modules. In this lab, we are going to deploy a virtual server for application publishing. Virtual server is a listener and this virtual server configuration is part of local traffic manager module. Also, we are going to protect the configured virtual server using a web application firewall policy. This web application firewall policy configuration is part of application security manager module. Therefore, we will provision two modules, which is LTM and ASM. When you check this box, you have couple of provisioning options. which is nominal, minimum and dedicated. We will discuss each one of them in detail. In nominal, the recommended amount of system resources like CPU and memory is allocated by the system. FI always recommend to use nominal. Why? Because it allows the tenant to function properly under normal workloads without overusing the system resources. For example, it is like you are going to Pizza Hut and ordering a medium sized pizza, which is the right amount for a regular meal. In minimum, system allocates the minimum amount of CPU and memory required to run the tenant. This is suitable for testing or low traffic environments. Definitely, it is not recommended for production use because due to the limited resources. For example, it is like you are going to Pizza Hut and ordering a small snack meal, which is enough to survive, but it is not ideal for full use. In dedicated, the system allocates the maximum possible resources to the tenant, which are not shared with others. This is suitable for high performance or production workloads where the performance is critical. For example, like getting a large pizza just for yourself, and whether you eat it or not doesn't matter, but strictly no sharing. In this lab, we will use the FI recommended nominal option for both LTM and ASM modules. Based on the module selection, the resource allocation chart displays the corresponding values. Click Next to proceed. When you click Next, you will receive a warning because reprovisioning will restart either demands or reboot the tenant itself. So be careful. Modifying module provisioning impacts the tenant operations. Click OK to continue. The system will reboot to allocate the required resources to the modules. Usually, the resource provisioning takes 2 to 3 minutes. Wait for the resource provisioning to complete. Once the provisioning is finished, the system will take you to the device certificate section. Task 4. Renew the tenant management certificate using the tenant hostname and IP address. FI provides default self-signed certificate for the device management using the default hostname. The device certificate is important because modern browsers validate the IP address or hostname against the subject alternate name entries in the certificates. Since we will be changing the device name, you should create a new device certificate using the renew option. Click renew and fill the certificate properties. Choose issuer as self because this is FI self-signed certificate. Type the common name as the tenant hostname, which is prod lb1.lab.ae. For division, set it as IT or ICT. For organization, set it as lab since this is for the lab environment. For locality, since I am based in Abu Dhabi, set it as AUH. For country, since I am living in UAE, choose AE. Enter the email address. Set certificate lifetime. By default, the certificate lifetime is 365 days. I'm just putting longer lifetime. In the subject alternate name, enter the following entries to ensure the browser validates the hostname or IP address correctly. These entries are LB hostname and IP address. Leave the key settings as default and click Finished. When you click Finished, the system generates the new certificate and assigns to the tenant management web access. As a result, your browser will revalidate the connection and you may receive a certificate warning. Open the certificate details to confirm that the system is using the new certificate which you have created now. Then proceed to continue. You will see the new certificate listed inside. This completes the device certificate setup. Click Next. It will take you to the platform configuration page. Task 5. Configure the tenant hostname, time zone, and the root password. In the platform configuration page, verify the management IP, subnet mask, and the default gateway is configured correctly. Also, set the new hostname for the tenant, which is prodlb1.lab.ae. Also, set the time zone based on your location. For example, since I'm living in UAE, I set the time zone as Asia Dubai. The time zone is important to reflect the correct timing in your logs. Then set the root account password. Once you are done with these settings, click Next to complete the platform configuration. When you click Next, the platform settings are completed and as the result, the page title changed from the default name to the new host name set by you. Also, this will take you to the network configuration page. We will not use the configuration utility for network setup because we will configure the network settings using the TMOS web UI, which provides a clear understanding of trunks, VLANs, self IPs and floating IPs. So click Finished here. When you click Finished, that will take you to the FI TMOS web UI main page, where you can see all the modules listed on the left side. Task 6. Setting up the DNS servers and the search domain for the tenant. Also, test the name resolution using the configured DNS servers. There is a question here. Why do we need DNS servers and search domain for the tenant? Great question. DNS configuration is important for the tenant because it is required for FI license activation, FI signature updates, LDAP authentication, Kerberos authentication, and much more. Alright, let us configure the DNS settings. To configure the DNS, navigate to System, Configuration, Device, DNS. Under the DNS lookup server list, type the DNS server addresses. In our lab environment, we have two DNS servers. Let us add one by one. The first one is 10.10.10.10. The second one is 10.20.10.10. We have added both the DNS servers successfully. Also, it is important to configure the DNS search domain because it helps the system automatically append domain suffixes when it resolving unqualified host names. Alright, what is qualified and unqualified host names. Qualified hostname is FQDN, which is the name append with the correct domain name. For example, prod lb1.lab.ae is qualified hostname. Then what is unqualified hostname? Unqualified hostname is short name which is just a name without appending the domain name. For example, prod lb1. Let's say you have the following search domains configured in the tenant, which is lab.ae and lab.local. If the system encounters the hostname as prod lb1, it automatically attempt to resolve prod lb1.lab.ae. If that fails, then it will try to resolve prod lb1.lab.local. This process continues in the order until it finds a match or run out of options. In our lab, we set one search domain, which is lab.ae. Our scope is not limited to just configuring the DNS and search domains. Also, we need to test the DNS name resolution and the search domain is correctly added when the system encounters unqualified hostname. Alright, to test this, we need to log into the tenant CLI. Important point to note here. By default, CLI terminal access for admin account is disabled. We have to enable it in order to access the CLI. To enable this, go to the system, users and click on admin account to edit. Here, navigate to terminal access and enable either TMOS cell or advanced cell. TMOS cell will take the user directly to the TMSH cell, whereas advanced cell takes the user directly to the Linux cell. Commonly, we refer the Linux cell as base. If you are a device administrator, you can switch between TMOS and base as needed. Use base from TMOS to enter base and type TMOS from base to return to TMOS. In our lab, we have enabled advanced cell access for the admin account. Also, we connected to the device through SSH. Now we are into the FI CLI. Make sure we are in the base cell. For the DNS lookup testing, you can use either dig or ns lookup command in base cell. Let us use the dig command to test the DNS resolution. For example, dig lab.ae. Alright, it is resolving correctly. Let us try to resolve few more domains, which is dig prod lb1.lab.ae and dig google.ae. Great, all the name resolutions are working correct as expected. I am not going to use dig or ns lookup to test the search domain resolution because they do not always respect search domains well. To test the search domain, I am going to use a newer command which is getent. Getent stands for get entries. It is a Linux command that properly applies for search domains. Let us try this with unqualified hostname, which is prod lb1. Great, it appends the search domain and resolves correctly as prod lb1.lab.ae. To demonstrate clearly, I will remove the search domain settings. Now, let us try the same unqualified hostname, which is prod lb1 again. Oops, it fails to resolve and the system doesn't append any domain suffix. This confirms the importance of the DNS search domain configuration. The DNS search domain helps the system automatically complete unqualified hostname during the name resolution. Alright, this completes the domain settings and testing the name resolution using domain settings. Task 7. Configure NTP servers and verify the time synchronization. Now, let us configure the NTP settings. There is a question here. Why do we need NTP and time synchronization in tenant? Great question. NTP and accurate time synchronization is important for license validation. Many licenses are time sensitive and that require the device clock to be accurate for the validation checks. Also, for device high availability synchronization, accurate time is essential for event coordination, failover decisions, and state replication between high availability peers. Also, time synchronization is important for authentication mechanisms. Protocols like Kerberos rely on timestamp based tokens and clock skew can cause authentication failures. Also, time synchronization is important for log validation and correlation. Time synchronized logs ensure accurate forensic analysis, troubleshooting, and even correlation across the systems. So, the time mismatch can lead to failures in these critical functions, and configuring the NTP is highly recommended. To configure the NTP servers, go to the Configuration, System, Device, NTP. Then add the NTP servers. If you have multiple servers, add them one by one. In our case, we have two NTP servers. We are adding them one by one, which is 10.10.10.10 and 10.20.10.10. We have added both the NTP servers successfully. Once configured, make sure the system is properly synchronized the time with the NTP servers. To verify the NTP synchronization, log into the FI CLI and make sure you are in base cell. Then run the following command, which is ntpq-np. Then look for a star or plus symbol in front of the NTP server IPs which is listed on the CLI. Alright, what is star and plus? Star indicates the primary NTP server currently in sync. Plus indicates a backup NTP server that is reachable and usable. In our lab, we have two NTP servers configured. And 10.10.10.10 is the one currently synchronizing the time. You will see star in front of it. To verify the current system time, type clock. This displays the current time of the system. Great! We have configured and tested NTP successfully. Time synchronization is working correctly. Task 8. Verify the LAG interfaces are inherited from the rSeries host to tenant. This is to check whether the HA and data LAGs are inherited from the host to tenant. Important point to note here. We know the FI has renamed trunks to LAG on the rSeries host. But the tenants still display this name as trunk. No worries, it is a cosmetic difference. You just need to aware. To verify the LAG details on the tenant, go to Network and Trunks. Here, verify that the LAGs are listed correctly. Yes, both the data and HA-LAGs are listed correctly. Click on the data LAG to verify that the ports 1 and 2 are listed correctly. Yes, the ports 1 and 2 are listed correctly in data LAG. Also, click on the HA-LAG to verify that the ports 3 and 4 are listed correctly. Yes, the ports 3 and 4 are listed correctly in HA-LAG. This confirms the data and HA-LAGs are inherited from the rSeries host to tenant successfully. Task 9. Verify the data and HA VLANs are inherited from the rSeries host to tenant. To verify this, go to Network, VLANs and verify that the data and HA VLANs are listed correctly. Yes, we could see all the data VLANs, which is VLAN 230 and VLAN 231 and HA VLANs, VLAN 4001 are listed and mapped to the correct LAG. This confirms that the data and HA VLANs are inherited from the rSeries host to tenant successfully. Alright, we are done with the tenant 1 setup on host 1. Let us repeat the same steps to set up the tenant 2 on host 2. We have followed the same process and successfully set up the tenant 2 on host 2. Now, both the tenants, which is prod lb1.lab.ae and prod lb2.lab.ae have been successfully configured with the basic setup. Please watch my next video, which is rSeries tenant networking and high availability. In that video, we will configure the data network self-IP for client-side and server-side VLANs. Also, we will configure the HA network self-IP for HA VLAN. Also, we will discuss the rSeries high availability. Also, we will set up the HA between tenant 1 and tenant 2 using the configured HA VLAN. Also, we will configure the routing and test HA synchronization. Thank you for watching.